Hello friends, welcome to Risingpearl.com. We are on series 2 where we are learning about triangles. Today is webisode number 9, and friends, today we are going to talk about solving questions, problems on basic proportionality theorem and the last two theorems, and we are calling this a part 2. In webisode 8, we started looking at solving problems, questions on these three theorems, so that was a part 1. So what are the three theorems or concepts we are talking about? The first one is basic proportionality theorem, also known as Thales theorem. We looked at this in episode number 5. The next theorem was in a triangle, if a line is drawn parallel to one side of a triangle, then that line divides other two sides in the same ratio. We looked at this very important theorem in webisode number 6. And the last concept of theorem is, in a triangle, if a line divides any two sides in the same ratio, then that line is parallel to the third side. As you can see friends, second and third theorem, they are really converse of one another. And we saw the last one on webisode number 7. As I had mentioned in these two webisodes that these two theorems are very, very important when it comes to the concept about similar triangles and questions on similar triangles. I'm going to provide a list of the URLs, the links for these webisodes below for your quick reference. Now, before we jump into the actual questions, I wanted to just design our strategy. And you will see as we solve all these different questions, we will really make use of this. So the first thing that we are looking for are which ratios. So in the question, we will want to understand which are the ratios very clearly. Second, which triangles are involved or may be involved. So we will be keeping an eye out for which triangles are involved in the question. And finally, we are also going to be looking at, is there any line inside triangle that is parallel to one of the sides, and which side? So I have just listed them as 1, 2, 3. It does not really mean that step 1, step 2, step 3. These are the very basic things that we are going to be always on the lookout when we solve questions related to similar triangles. As you can see, they are all related. Second theorem and third theorem, even basic proportionality theorem, they are all talking in the context of a triangle. Not a square, rectangle, quadrilateral, or anything. They are all talking about triangle, and there is always a line which is parallel to one side, and if that is the case, it divides the other two sides in the same ratio. Now, having said all that, let's take a look at some real questions. So first, this is the question number 1. Question 1. PQRS is a trapezium. PQ is parallel to RS. X and Y are 2 points on non-parallel sides PS, QR respectively, such that XY parallel to PQ. Prove that. We have to prove a ratio. So first things first here. Friends, you are noticing we are not given any figure, so we have to draw it ourselves. Whenever we have to do any construction, or not really construction, whenever we have to draw our own shape, figure, we always draw the most basic shape or figure. We are not looking to draw anything fancy. We are going to look at step by step and then draw our shape. So the first thing is we have to draw a trapezium. What is a trapezium? Trapezium is a quadrilateral which has only one pair of opposite sides parallel. So we have drawn trapezium PQRS such that PQ is parallel to RS, and PS and QR are the non-parallel side. So PQ parallel to RS, we have drawn PQ parallel to RS. X and Y are 2 points on non-parallel sides PS, QR respectively. So this is PS. X is any point on this side and Y is any point on this side. The only thing we know about these 2 points is that if you join x, y, that will be parallel to PQ. That means if I take x here, then I draw a line parallel, straight line like this, then that line, and cutting here on y, that line will be parallel to PQ. If I take x here and draw a parallel line to PQ, then that line will cut this side here at y. So I can pick x anywhere. So let us just pick a particular spot. So here what I have done is I have picked x here and drawn a line xy which is parallel to PQ. So we have completely drawn our shape. Now what do we need to prove? Now we have to focus on which ratios. We need to prove px by xs. So px divided by xs is equal to the ratio qy by yr. Now friends, remember that we have the ratios. Whenever we talk about ratios, we talk about ratios in context of a triangle, right? So we need to create a triangle. So how can we create a triangle here? We can join either SQ diagonal, then we will have 2 triangles, or we can join PR diagonal, and then we will have 2 triangles. So in this video, I'm going to actually join SQ. I would strongly suggest for you to, instead of joining SQ, you join PR and solve the same question. The idea will be exactly the same. The moment you join SQ, you have 2 triangles, this triangle and this triangle. We will take a look at each triangle one by one. First, we will take a look at triangle SPQ. So in our triangle SPQ, you will notice that XT is parallel to PQ. So it means these ratios, let's write the ratio now, XS divided by XS divided by PX equal to ST divided by QT. Why? Because in this triangle SPQ, XT is such a line that is parallel to side PQ. Right? So in triangle SPQ, this line is parallel to one of the sides of the triangle. So this line divides these 2 sides in the same ratio. So XS divided by PX must be equal to ST divided by TQ. Now in the question we want PX by XS. So we are just going to take a reciprocal of this so that PX comes on the numerator. So then we can write this as PX divided by XS equal to QT divided by ST. Let's call this our equation number 1. Similarly, in this triangle QSR, let's write it here. In triangle QSR, what do we have? We have TY, this line, parallel to SR or RS. Why? Again, recall friends that if XY is parallel to PQ, and PQ is parallel to RS, right? Then all 3 lines are parallel to one another. So here we have TY parallel to RS. So that means this line must divide SQ and QR in equal ratio. So let's write the ratio. So QT divided by st must be equal to qy divided by yr, right? Let's call this our second condition. If you look at this condition, px by xs equal to qt by st, and then from second condition qt by st equal to qy by this, you have this as a common ratio in both equations. That means all of these three ratios are same, and hence from 1 and 2 it implies that px divided by xs is equal to qy divided by yr. So we have px divided by xs equal to qy divided by yr, which is what we need to prove. So friends, here we have actually solved the question. So as you notice, friends, just to quickly recap, we looked at which lines are parallel and what are the triangles, and because we are interested in this ratio first, so we express this ratio equal to this intermediate ratio, and then in this other triangle we prove that this ratio is equal to the other ratio. So from equation 1, equation 2, these two ratios are equal. You will see this approach as a general theme for most of these questions. So here, friends, we have question number 2. This is our second question. Now, in this case, friends, the good news is we have been given a figure. So in the figure below, we have a figure like this. AX is parallel to RS. So which is AX? AX is this side. This is parallel to RS, this side. And BX, this side, is parallel to ST. Now friends, if you look at this triangle, it may see this shape, it may look like some sort of a 3D pyramid or something. So let your imagination not run wild here. Simply it's a two-dimensional shape, and there are basically two triangles. We have a triangle here and we have a triangle here, right? Now there are two parts to this question number 2. So first part is prove that the ratio PA by AR is equal to PB by BT. So how can we do it? Again, the way we did it in the last question, friends, we are going to first try and figure out what is given. We have these two lines parallel, which is given. So if I look at triangle PRS, if I look at triangle PRS, in triangle PRS, you have AX parallel to RS. That means this ratio PA by AR, it means PA by AR, it must be equal to PX by XS. PX by XS. Why? Because AX is parallel to RS. So from the theorem, these two ratios must be equal. Let's call this a condition 1. Similarly, in the second triangle PST, we have two triangles given here, and this line is parallel to this line. So we have to really make use of this information too, right? So we say that in triangle PST, what do we have? BX is parallel to ST. So these two ratios, that is PX by XS, must be equal to PB by BT. So we write PX by XS xs must be equal to pb divided by bt. Why? Because in this case xb or bx, doesn't matter how you write it, is parallel to st. This is given, and so from theorem we can write it. Let's call this condition number 2. So if you look at condition number 1, condition number 2, or equation 1, equation 2, you have PA by AR. Let's write it here. You have PA by AR, right? This ratio is equal to PX by XS, which is equal to PB divided by BT. So I have three ratios which are same. That means I can say that these two ratios are equal. All three are equal. So from here it implies PA by AR is equal to PB by BT. So if you look at it, friends, PA by AR is equal to PB by BT, which is exactly what we have proved. So again, like our first question, in this question we started out with one ratio. We used the information, we used the second theorem and the third theorem, whereby we have parallel line inside a triangle. We have identified a triangle and we express that ratio being equal to an intermediate ratio, and from the other triangle we use that intermediate ratio being equal to the final ratio. And so from equation 1, equation 2, we have found out that we have proven that PA by AR is indeed equal to PB by BT. So friends, I hope that you are seeing the pattern, how we are solving these questions. In the next video, we are going to continue to see some more examples on solving these problems using the three theorems.